Okay, well, I'm just going to get started. We're in for a really fun but fast session on reinventing housing. I realize that we don't have a lot of time. One of the things that we all agreed to do is to show a little bit of what we do so that we're not sort of talking into air and trying to explain things that most people are, things that are unfamiliar to most people. So what I'm going to do is call up each one of the panelists and just ask them to say a little bit about their work, and then we'll start. So I think if I can do this properly. Here we go. Okay, great. So Dan, I'm going to have you come up first and just say a few things. Maybe you can introduce your title too.
Okay. Good morning. My name is Dan Gainsboro, and I am the president and CEO of Now Communities. And Now Communities creates infill neighborhoods where for people who want greater connection and are looking, while having living in architecturally vibrant homes that use less energy and require minimal maintenance to maintain them. We work in 2 scales, and if I can figure out how to operate this, I'll...
Just the big green button.
The big green button.
Yeah, there you go.
And that's the last slide I want to show you. That's okay. I probably put it in that order. We work in scale basically of communities that range from 8 to 16. This is probably our most well-known project. It is built in Concord, Massachusetts, and it's Concord Riverwalk. This was a total of 13 homes, and these are all net zero possible homes. So now I'm going to try to go backwards. And that didn't work. How about that? There you go. This is a project that's we're currently permitting. This will be 18 homes in Carlisle, Massachusetts. Also will be net zero possible. And then, if I push the right button, this is a project that we're doing in Devens, Massachusetts. And this will be 120 homes when we're completed. This is the first phase. There will be a combination of attached and detached homes, as well as a 40-unit rental apartment building. The critical things about our projects in terms of technology have to do both with perhaps maybe more low-tech in terms of creating environments for people that focus on placemaking and creating really architecturally rich environments that give people, the residents, a chance to get to know their neighbors and walk, as you can see, through the community. And so from my perspective, that's a little less reliant upon technology in its purest sense, but it has to do with a previous time where we actually knew our neighbors and got out of our houses and interacted with one another. On the more high technology side, and this is the slide I think I started with, we do put a lot of energy into designing a high-performance building envelope. So as I mentioned, our homes are designed to be net zero possible, and that starts from the foundation. We're now using, which is also an attempt to utilize technology, we're using a plastic foundation that includes the insulation and the air sealing, and they are erected in about 2 to 3 hours. And what's really important from a building science perspective is when you do a really tight building, and our buildings are very tight, you don't really want to be introducing a whole lot of water into it. And anyone that's worked with concrete knows that entails a lot of water. So it takes a long time for that moisture to get out of the building. I don't know how much further you want me to go.
No, that's good.
Okay, thank you. Thanks.
So next we have Steve Glenn.
Quick survey. Hold your hands up, or put your hands up, if you've ever built a home ground up. Keep them up if it came in on schedule. Keep them up if it came in on budget. Okay, no hands up. All right, so let me show you another way of doing this. We design and develop high quality, custom, very sustainable, LEED Platinum level, single and multifamily homes. We build in a controlled all-weather facility. Our staff are full-time as opposed to subs. So what's cool about this is that we're able to build in parallel to the site work, right? Typically, you will do the grading, foundation, utilities, et cetera, before you can start framing, electrical, plumbing, trades, rest of the trades. Here, as the site work was happening for this 16-unit multifamily project in Berkeley, we were building in the factory. Over a period of 3.5 months, we shipped one day, and we installed in 11 hours the next day. And the total time from beginning of production to certificate of occupancy was about 9 months for this 16-unit multifamily in Berkeley, which is half the time plus that it would typically take. The modules come super complete, all finished plumbing and electrical, all cladding, all millwork, appliances installed, tiles grouted. We did it for about 20%, 15 to 20% less cost than it would cost to do this site built. So that's what we do. We're investing in 2 enabling technologies to do this better. So the process of building a home, this media lab, a football stadium, all has kind of 3 big chunks that cost time and money, right? Design, permitting, construction. Permitting's like way beyond our pay grade. We're not doing anything to make that more efficient because we can't. But on the design side, we have a set of web-based apps that make it easier for you to design and configure homes. We've got a marketplace that has standard homes from world-class architects like Yves Bahar, Ray Cappy, Kieran Timberlake, that you can configure like cars. We just introduced one that allows you to enter in an address for any site. Currently, LA County will roll out to other cities, and it'll show you what your zoning, your building envelope is, and then you can cycle through standard homes you can build there. And then we're also building out a set of building components, basically our own Legos, so that we can more efficiently build what we build. We did a big financing. Amazon actually invested in us. We'll be rolling out more factories across the country. Thank you.
Axel?
So, good morning. Good morning, everybody. My name is Axel Lerche. I am the Chief Development Officer and co-founder of EcoSmart Solution. Our business is currently based in Austin, Texas. You probably notice my Texan accent. I'm German Canadian, and I remember my high school teacher, when I got my high school diploma, said, "Axel, whatever you do, don't do it in English." And now I'm here at the MIT, which is an amazing experience, and I appreciate the invitation. I want to talk about EcoSmart from a community standpoint and level. Let's get that started. Same problem. Yeah, that's actually a good slide. Lots of information. So EcoSmart is an energy service provider as part of the land development team. We are a subsidiary of Taurus Investment Holdings. Our joint venture partner is Shell New Energy. And we try to accomplish to implement good technology, energy efficient technology from a community development standpoint, like you do it with water, like you do it with roads or electric. And we do the same thing with energy efficient technologies. You'll see some information about our companies on the top right side and on the left bottom side under this little schematic, you'll see the name Whisper Valley. That's our launch project. Whisper Valley in Austin, Texas is a 7,500 home community, 2 million square feet of commercial space, 2 school sites, a land development project of Taurus Investment Holdings. And we are including our technology for every home. So every home in Whisper Valley is, we call it zero energy capable, has very low hearth ratings. And it's a very simple mathematic approach. We help homeowners to harvest energy savings and actually to pay back for good technologies through a slightly higher mortgage. And again, the difference to a lot of other projects is we do that on a community base. I'd like to highlight pretty much our unique approach to reduce heating, cooling, demand in houses. We believe that is the biggest challenge, and actually it's more important to reduce electricity demand in those homes. To reduce energy and electricity demand in those homes, and then to think about solar. So if you see this schematic and you envision one house times 7,500, you see on the left side what we call a geogrid. A geogrid is a thermal energy exchange system which is installed like a water line. It is connected with every house. It provides very clean and energy efficient geothermal heat and cooling. So this is installed before we even did the roads, or like again, in the same way we install water lines. And then on the right side, our company provides for every homeowner an energy efficient package in and on top of the house. So smart ground source heat pumps, roof and carport photovoltaic, energy storage in the future. Every home is smart EV charger ready, has smart thermostats and energy efficient appliances. That package is in every house. It's very scalable, and it's predictable, and it is affordable, because energy efficient technology becomes simply cheaper if you do it upfront and you do it scalable and you do it in a very efficient way. Whisper Valley is our launch project. We are right now in consideration of various other so-called master plan communities. Just one last number, 650,000 homes, new homes constructed in America every year. Actually, 80% of those 650,000 homes are built by 10 large so-called production builder. So it's a very concentrated business. Our goal is to service about 5 to 10% of all those new homes with our EcoSmart solution. Thank you very much, and I'm excited, Larry, to the discussion. Yeah, I remember we had a panel discussion before on the phone, and we talked for almost 90 minutes, and I said we should have recorded that. That was the panel discussion.
That would have saved us a lot of time. All right, so I'll show you a quick little thing on what I do. So I'm in the Department of Architecture. My area of research is computation. I mostly work on software projects with other faculty. And one of the things that I have always been interested in is home delivery. How do you deliver houses at a much lower cost or price point? And one of the things that you really learn a lot about it here at MIT is dealing with systems. So one of the things that we discovered early in my research group is that there are three real core functions with the production, any wooden production of production of any wooden product. One is manufacturing parts, measuring parts, and then assembling parts. So this animation just shows a traditional construction. Putting sheathing on the side of a little tool shed, but it deals with those same three core functions. And if you think about how a car is manufactured, human beings really don't operate this way, or a car manufacturer doesn't operate this way with human labor. It really takes a lot from computer modeling and manufacturing. So what I've been working on for the past, I'd say 2 decades now, has been ways of manufacturing houses directly from computer models. Very much like 3D printing, and I've been working on a software package with another faculty from Singapore, part of a startup there. I've been working on that for the past 8 years. And what it does is it takes an STL model, same one that you would 3D print. It can decompose it in many different ways, the way that this is a traditional 3D printing method, which is slicing or cutting up parts into hashes. Or we can also make plate structures. And what it'll allow us to do is very quickly go from a 3D model to 2D drawings for machine cutting. And I had the great opportunity to put this into action back in 2008. I built a cabin with a group of students, well, more than a cabin, a pretty large structure at the Museum of Modern Art. And it was part of a show on home delivery. And the software works very much the way that we would have wanted it to work back in 2008. When we did that project, we modeled everything by hand. But over the past 10 years, we've been able to do this, where it immediately generates cut sheets and cut parts with numbers on them, and numbers tell you how to put the parts together. And very quickly, you can end up with in this case, a desktop model, but it's the same steps and systems that would be used to make a large object, a house. And every semester I teach some form of this with students. So digital fabrication is part of the educational system for most schools of architecture. The big question is, how do we scale this up? How do we write software for it? for the construction industry. And I think it's a great time to talk about this because now we're right at the beginning of the tech boom for construction. For many years, almost pretty much my entire career, I've hoped that this would happen where investors would see the possibilities with construction and investing in technology. And I do believe that this is a near future for us now that people are starting to step into the fold. So I wanted to start off by asking the panel a couple of questions about delivery and mostly just delivery of product, because that's where it really boils down to problems and solving problems. It's trying to figure out how you can deliver your product at a reasonable price and profit, right? Because that profit is always difficult, especially for Dan. Developers tend to work, especially housing, with very fine margins. So I was wondering if you could expand on that. You showed in your slides what you do. I was wondering if you could summarize specifically what you've done technologically that's different in advance.
Sure. So a couple of things. As I mentioned, the community design piece of it tends to be a little bit more low technology, but it's what draws in our buyers. They're very enamored with that. The building shell itself, the envelope, has more technologies involved in it. We have explored over the years different delivery systems. We've explored panelized. We've done some research. We haven't built a project using modules yet. And so as an early adopter and as to your point, Larry, as a developer, I'm always looking for ways to do things faster, cheaper, better. And certainly if you think about the 4 buckets of tasks that I spend my time on, finding land, getting it approved, and then building it and selling it, delivering it. The third bucket, the construction, is probably the greatest opportunity for technology to kick in and to provide some advantages. We have found so far that site built is very hard to overcome, the cost advantages of them, and now what used to be a fairly significant time compression with factory built housing. Even my site guys are doing a great job of compressing that. So we're putting up those homes that you saw in Devon's. They're framing them and enclosing them in 5 days, which is pretty remarkable. There is another answer to your question in terms of products, and I think it has to do with what products can the industry provide, whether it's an R-zip, which is an insulated zip wall system, which our tradespeople are very familiar with, and it saves a step and not having to go around the house one more time. Those things, trusses, factory-built trusses, all those things that are still within the realm of skilled tradesmen that's familiar with wood are what's been basically happening. Slow industry to adopt.
Okay. Steve, do you want to follow up, and then I'll finish off with Axel?
Yeah, so there are 2 major, really 3 major prefab building systems. One is manufactured homes, what the industry calls mobile homes. That's HUD code. We'll set that aside. The 2 major systems that you can use to do permanently attached homes, because you can't do that for mobile homes. So modular, volumetric system. The advantages I shared earlier, parallel construction, you can leverage off-site lower cost labor, no weather delays, all that fun stuff. The downside is, first of all, for people doing custom projects, which are really urban projects, infill projects, they're big Lego pieces. It's kind of hard to put them together to solve a number of different building situations. They also contain a lot of air, and it turns out it's expensive to ship air, $10 to $15, at least on the West Coast, per mod, per mile, and it doesn't scale elegantly. And oh, by the way, there are limitations on how wide and how tall they can be, so problematic in that perspective. Panels, that's another major building system in the industry. Panels ship flat, so much more efficient to transport. Creatively, you can combine them in much more precise ways, so you can solve more building problems. The challenge is that the state of the art currently, maybe you've heard of a SIP, a structural insulated panel, that's basically framing and insulation. You still have to do electrical, plumbing, cladding, if it's kitchen, bath, millwork, tiles, appliances, windows. Just more work. That's why we're working, frankly, on a hybrid system, a new kind of panel that comes more complete, and then kitchens, baths, utility cores in small modules, because that's the expensive parts of the home. So greater creative flexibility and greater transportation efficiency. Worth mentioning that as autonomous vehicles come online, and there are many people working on trucks, that's going to help on the transport side. And then there are a number of startups working on robotic solutions for the site that also will have a significant impact on site-based construction costs.
Okay, Axel? Just to be clear, because you're talking about delivery of energy systems, is that right? Geothermal?
Yes, yes. And by the way, I fully agree with the importance of the construction element. Prefabbed homes, 3D homes. I just spent a night in the Icon 3D home in Austin, Texas. They looked for a tall guy, and because it's a small home, and it was very nice and interesting. Actually, I believe there's another level of coming together in simply producing and offering better homes in America, and that is the level of infrastructure. I think actually it's a business model. Right now you have great technology, you have great builder, great community developer, and you have homeowner, and there's a gap between, because in most cases it's all about pricing. And it's all about, I mean, we know budget limitations are significant, and it's all about delivering the best for the most affordable price. And it is an opportunity to access savings on the long term on the homeowner side if it comes to utility bills. So if we build better homes, if we provide better infrastructure from a land development standpoint, who pays for all of it? And our model includes, we are financing that infrastructure. If I talk about the GeoGrid, EcoSmart is financing that investment. And we come into an arrangement with our homeowners, with the residents, to pay us back over a long period of time, pretty much simply through their energy savings. And I think that model applies for almost any better home. If it is a better home from a construction side, from a technology side, and it makes the role and this third party, the land developer, so important. Our CEO of Taurus, Peter Merrigan, would say, we own the dirt. A land developer, they do so many things already in HOA regulations, and some are probably wrong, but in amenities, they decide how to create roads and the landscaping and so forth. Why not doing the same thing from an infrastructure standpoint, lot orientation standpoint, design standpoint? Because if you do it from a land planning, or in this phase, in this early phase, is so much easier to apply it in every house.
But you just mentioned, I just heard you mention subsidies. What happens when those subsidies go away?
I mean, first of all...
will your technology be affordable?
Yes, so our entire business model is not based on any subsidies. We like the fact that our homeowners in Whisper Valley receive the ITC tax credit, about 7,000 to 10,000 homes. The house price in Whisper Valley is between, the cheapest house was sold for $219,000. The median house price in Austin is $360,000, and that homeowner received a tax credit of $7,000 to $10,000. That's great. I think that's pushing the business in the right direction. I personally believe subsidies are thin ice because a lot of industries, and I'm saying that also with my German background, are where the solar industry crashed because the government took away the subsidies within 24 hours. So I think a healthy business model has to be independent from incentives, but it helps. And I think we all agree on that, long term at least.
Okay, so I'd like to actually ask some questions about finishes, because most of the stuff that we show are framing, and we talk a lot about framing. Finishes in buildings take a very long time. Mm-hmm. Framing, door openings, things that most homeowners usually don't pay attention to, but you wait a very long time for them to happen. I was wondering what your experiences have been around finishes and buttoning up a project.
Would you mind going back to the slide of the Riverwalk slide? Because I think a picture might be helpful for people.
Yeah, that's great. Let's see if I could.
I'm going to let you do it because I'll.
Yeah, here we go. Hold on, let's try. We got.
There.
It's the pen in reverse now.
So I just want to point this out because Riverwalk, as I mentioned, is a net zero possible community. The boxes, the building envelope, my perspective, there's a lot of details on those houses, right? And, but it's somewhat deceiving in that we built a very simple box, and then we did a bunch of overframing, which would fall really nicely into what Steve can do for us. And actually, there were 10 new homes. The last one on the left, which you can just barely see, we panelized. And where it was taking us about 2 weeks to frame and enclose and put on the different overframing, when we did that one, it took us 2.5 days, and without eliminating any of the details. So it is possible to do. You need to look for strategies where you have, in our case, it was a site-built project, and we had a very engaged builder that was constantly looking to try to figure out how to spend less time in each one of those houses without sacrificing craft, because the craft relates not only in terms of the finished product, but also in terms of the building performance. These houses use about 70% less energy than a typical home before we put any panels on them, so it's a big deal. And I think Steve or Axel made that point that Axel did. This is real money. And one of the challenges I have as a developer is we bake all this stuff into the house, and folks, the buyers, don't quite appreciate that. So there's a learning curve involved in educating them that this is real dollars in their pocket.
Steve, can you comment on?
Yeah, well, I mean, finishes people see pretty directly. We have two sets of clients. One are individuals who are doing their own homes, and the other are developers. Developers definitely will ask about what's behind the walls in terms of insulation and how we do certain details. They care a lot about durability, which is to say liability. Most of our homeowners aren't as sophisticated about what's behind the wall, but they look at finishes, and they want them to be high quality. They want them to reflect the form and functionality that they care about. So we take great care to try to deliver on that. But one thing which just touched on that we think a lot about is where those finishes come from. The most important thing to get right in the built environment, sorry to kind of go all climate change on you, but is energy. Your building will use far more energy over its useful life than is embodied in the materials. Nonetheless, there are lots of materials can be kind of viewed in what's the ecological footprint, what's the carbon required to create, can it be recycled, what are the health implications, does it have nasty compounds like formaldehyde, urea, that get off gas. So we try to really understand that too, and thankfully more and more consumers care about that, and some don't, but we try to build in a responsible way anyway.
I just want to mention that, because I did mostly focus on the outside, Steve's point earlier, this opportunity to create modules for things like kitchens and baths would be incredibly attractive to somebody like me. And it's almost like a plug and play if we could do that, because I do believe that the level of quality outcome is better in a factory, even with my site build finished trades in particular.
Yeah, I'd like to turn over, before you say something, I'm going to throw one more thing in. Before I turn it over to the audience, I wanted to ask one last question, because I'm worried that we'll run out of time at the end. So I just wanted to ask the main mandate that we've been asked to talk about, which is reinventing housing. Based on, with all three of you, what you do and what you produce, 20 years from now, can you predict a difference in, what do you see different in a house? You're showing traditional styles, traditional designs. Does design change? Does the shape of the house change? And I also say that too because Dan lives in Concord, and I was just up there last week, and I noticed that you always see these enormous new houses alongside of a very small ranch house. And so it seems like the trend is building bigger, larger. I wonder, what is your outlook on the future?
I'll go last.
So I summarize also my thoughts about the discussion before very quickly. I'd like to include another layer of finishing, if I might say. It's the performance of a house. I think we need more measurement how a house performs, because that relates to dollar and cents. Dollar and cents, that creates investment potential. And if I say performance, I talk about data. And that already relates to your question, Larry. Data becomes more and more important. The house will be a measurable value for a homeowner, and the data is usable in measuring performance. And I'm also talking about certifications. I think I hear all those terms, and I use also one: zero energy capable, net zero possible. We have all those. I mean, who knows HERS rating really in this room? That's the official index in the United States to measure house performance. And we really have no clue what this is about. So I think also performance should be certified in a much more investment-orientated way. So that answers this question. A house in 20 years from now, just throwing in some numbers. About 40% of all home buyers in America are single person homes, or home buyers. 40%. That are folks, they live alone. They need a one-bedroom house. There's only, or maybe a two-bedroom house. There's only, I think, 2.5% houses built 2 bedrooms or smaller. So we have a huge discrepancy just from what the building industry is providing, large homes, and what the people are asking for. By the way, second largest group are single homes with a pet. That's the second largest group.
With a dog.
And then we talk, that's true. And then we talk about, like most of us, families and so forth. So I think the housing industry will adjust. That's where prefab homes, 3D printed homes, which can be built very quick and easy to satisfy the interest of the home buyers. That's number one. And number two, I truly believe that we will have, at least for new home construction over the next 20 years, communities who become smarter, because this is the most efficient, it's the lowest hanging fruit. Why don't we do it at least right when we build new? I mean, we know so much how difficult it is to retrofit. That's a completely different discussion. Why don't we at least take everything what we know and we put it together and we start doing it, and we do that on a community base, and that's what EcoSmart is doing with Taurus and Shell.
Steve?
So there's some cool trends happening in homes, but before looking 20 years out, but before I share, there is an increasing gap, particularly in cities, between supply and demand in a bad way, and particularly for workforce housing. There at least is tax credits, and in California at least more and more money going into affordable housing, homeless housing initiatives, workforce housing. There's no money, no tax credits available. It's increasingly an issue as land, labor, construction materials, even permit fees increases most dramatically in cities. But some things that are happening that I think will only accelerate over the next 20 years. First of all, cities are making it easier and easier to build smaller units. And one of the great trends in housing that's super exciting, I think, for all sorts of reasons, is that average home size is going down. It's actually happened over the last 2-3 years. It peaked at around 2,500 square feet. Hasn't gone down a lot, but like from 1950 on, it was just growing dramatically. So now it's starting to go down. And I think that's going to accelerate with things like the following. Minneapolis, a few months ago, actually passed new zoning that eliminated single-family home zoning in the city. So if you live in a single-family home in Minneapolis, you can now do multifamily. Now you're subject to density, coverage, and your lot size, et cetera, but you can do a duplex, triplex, quad. California, increasingly, a number of cities there have what are called the small lot ordinances. And basically, they're a package of variances, the two biggest of which is you can do zero lot, you can take a R2 or R3, so a piece of land zoned for multifamily, and you can do single-family homes with zero setbacks. So they look like townhomes when you look at them, but they actually don't share a wall. So they appraise as single-family home, no condo fees, you don't have the condo liability. So things like that, and cities, I don't know what's happening in Boston, but certainly New York, San Francisco, Los Angeles, making it easier to do smaller multifamily units. Those are some really exciting trends because there's nothing we can do outside of tax credits for land costs, labor costs, material costs. If you want more affordable housing in cities, you're going to have to create smaller units. That's it. And cities are making that easier to do. So that's exciting. I think we'll see a lot more of that in the next 20 years.
Okay.
Yeah, and I would echo what Steve said, and we see it in our business. Those units, by the way, are 13 to 1,500 square feet, wow. 2 and 3 bedroom, 2.5 bath. And a little nervous when I started, which was right in the last really bad recession, 2008. But people were all over it, and they really loved it. And so that was very, that gave me a lot of hope. The other thing also that Steve mentioned is we describe in the industry, we talk about the missing middle, which is, as I look out the window, I'm kind of seeing those, what that is 3 to 5 story buildings. It's a little more multifamily, and it's really the only way to solve this problem. Plus, when you get to those kind of buildings, you can start to utilize panelized and modules and things like that that really start to help the mono.
Okay, thank you. So I'd like to turn this over to the audience. If you have questions, please come up to the mic, if you don't mind.
Thank you for the presentation. I have 2 questions. One from Mr. Steve Glenn. You said that, sorry, you.
I'm Dan Steve, okay.
Yeah, it's for you, okay. You said net zero. Could you expand on that? Do you mean heating and cooling too in winter?
Yes.
You're providing net zero solution?
Yeah.
That's one question for you. And how do you do that?
Okay.
Second question for you, sir. Axel, Lerche, geothermals. Are you using groundwater at the normal temperature of 55 degrees Fahrenheit? How deep do you go? And could you expand on the geothermal aspect? Thank you.
If it's,
Hold on.
All right.
I think I could go forward and do it.
oh, there it is, one back. Okay, so just very quickly, the strategy for getting to net zero possible, and Steve mentioned it, and I think Axel alluded to it as well. You drive down the cost of the heating and cooling. So you do a high-performance building envelope, which reduces the load for heating and cooling by 60%. The source of heat in our homes are mini-split, air-source mini-split heat pumps, so electric. Our homes are all electric. There's no carbon systems in the buildings whatsoever. So that's how we're getting to, and then all the other systems, whether it's lighting, plugs, loads, appliances, they're all energy smart, they're LED lighting. So by the time before we even put any panels on the houses, and Axel mentioned this, we're hitting HERS rating of about 20 to 25 on these houses typically, which means that they're using 75 to 80% less energy. And then by virtue of adding solar panels on the roof, and in the Riverwalk project, we were very fortunate. It was stadium seating facing directly south, so all the houses could take advantage of.
But I want to throw a little question into the works, and it's really a question for Steve because we talk about prefab. How easy is it for you to retune your system to deal with a thicker wall, thicker panels, thicker?
Good question.
Is it an easy thing to change in your factory?
Yeah, easy. I mean, the big insight, we started a design firm to do what we hope to be standard, modern, LEED Platinum level homes. We designed the first LEED Platinum level home that was ever, certified home that was ever done. And what we quickly discovered, like the Bauhaus guys and the case study guys and Frank Lloyd Wright and a number of other great architects who tried to do standard prefab homes, is that the people who were buying them were often putting them in cities, and because of odd size lot requirements and zoning requirements and different design that varies neighborhood to neighborhood, we were having to customize floor plan and elevation. And so kind of the big insight that led to Plant was we were like, why don't we create a factory set up not to do standard low quality, non-sustainable kinds of homes, but rather custom high quality homes. Like if we did that right, we not only would solve our needs, but much more importantly from a business model standpoint, tens of thousands of people who are building homes and developers in cities in particular where you, as I said, you really have to do custom. So long answer, we have to be able to accommodate different building environments to be able to do that. Is it less efficient than building something like this again and again? Absolutely. But the good news is, you mentioned the car guys, the plane guys and the shipbuilders, and even the guys that do buses for cities, they've cracked the code of how to use off-site production to do custom projects more efficiently.
Can I just pick on that?
Sure, go ahead.
Just quickly.
Just quick, yeah.
I think Steve's making a huge point, because one of the hesitations of me as a developer, oftentimes looking at panelized, is that it doesn't allow for a lot of flexibility. And those firms that have figured out that unlock that value equation, that opens up a lot of doors. Our buyers still want customization. They want their unique homes. So that's critical.
Okay, next question.
I just want to address that question about geothermal, because you pushed the right button, and usually I talk about that for an hour, but I try to do it in 2 minutes. And it's important because I truly believe it's a completely underestimated great technology. So geothermal, or ground source heating, cooling, number one, is not tapping the earth core and we just get steam out of the earth. It's simply temperature exchange in a very low surface. To answer your question, the boreholes or loops are about 360 feet deep, and we are circulating, and it's called a closed loop system. We are circulating water in the summertime, lots of hot days in Austin, about 40 days, over 100 degrees. That's another aspect of changing of housing and energy demand. We are taking temperature through that water out of the house. We dump it in that loop, we dump it in the underground, and we provide colder temperature, and it's in reverse in the winter time. The challenge, it's great technology. It's we all know that it's in the markets for over 50 years. Two big challenges. It's a very expensive technology, especially all that stuff outside of the house. And number two, it is also very, from a construction standpoint, disruptive. It's simply not usable for a production builder who is building a house every day, because it's simply too complicated. So in the past, it was a good technology, mostly for high-end custom-built homes. People who could afford $1 million just spend another $50,000 in their ground source heating cooling system. In doing all that piping upfront from an infrastructure standpoint, if you will, it's an evolution. Like we did city water 50 years ago, everybody has as well, and then all of a sudden, municipalities introduced central and city water systems. We do the same thing in providing that thermal energy exchange capacity. So we drilled all the holes before, we connected them all through a horizontal piping, so we created a large thermal energy exchange system for all those single homes. The advantages, it's much cheaper to pre-install, about 50%. Number two, it's very easy for the production builder to hook up with the system. He's doing it like with the water line, identical approach. And number three, it becomes so much more affordable because we could take those costs and could provide the homeowner with a long-term payback plan, again, so the houses are not more expensive. And that is why I believe good technology needs, in most cases, a scalable approach. One last comment. In context, you mentioned building codes in California, in context of more and more requirements in regards of solar. When we talk about smaller homes, we have to realize, in most cases, there is not enough roof space anymore for enough solar if it is on every house. So then we think about community solar, but I think the first step needs to be get the electricity demand down, especially from a heating and cooling standpoint. Construction, I agree with you, Steve, and then think about renewable electricity generation. Helps the utility, helps the homeowner, helps the environment.
Last question, we'll do that really quick.
What is the value of energy efficiency for the buyer based off the dollar savings that they get on their energy cost, and also the value that they see that they're helping the world?
So when I can take a pass at it. In the case of our houses, let's say Riverwalk, for example, typical total energy cost would be, and we tracked it with people, under $75 a month. So compared to what a normal house that size might be $3,000 a year. So it's real.
Axel.
Yeah, so it's interesting. The industry is getting better. When we did Riverwalk, it was probably 10 to 15% premium on the overall cost of the house. Now, when we do Devon's, for example, it's probably under 5%. So it's worth it. I'm sorry? Yes. 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 Yeah. And as the industry, as the tradespeople become more and more familiar with it and comfortable with it, it's going to drive the cost down. And Larry had asked us another question in preparation in terms of what the industry can be doing to help. And certainly any products like an RZIP, like roof trusses, those things that the tradespeople are familiar with, that they can easily adapt with, they're going to be embraced very readily.
Actually, Axel and Steve, can you also address that same question? What
Great question.
can the industry offer? What can be offered from a research standpoint that could aid your business?
Well, it's interesting. If you look at buildings as a category versus all manufacturing and all transportation, buildings, I know the stats for the US, but I think this is true for the world too, use more energy, about 40% versus I think it's 29% for transportation, and I forget for industry, but it's smaller. Of all US energy consumption, and no surprise, it's about 39-40% carbon emissions. So for those of us who believe that we have a short period of time to dramatically change the way we produce products and the way we consume, buildings are sort of the place that we most need to focus. And so for appliances, for food, the government's mandated you have to have certain performance stats, so too for cars. But we don't have that for buildings. There is legislation in California. We have, you mentioned about HERS. Everybody who builds knows about HERS in California because we have mandatory, it's called Title 24, very, very high energy requirements. There is legislation right now, it's either in the Senate or the Assembly, proposed to make every home builder have to disclose certain performance metrics, resource performance metrics, energy, water, about their homes. And like that's a no-brainer. This should be part of the purchase disclosure. We should understand this about what we're getting. It should be valued in terms of developers who have the foresight to put this into your homes, which reduce your operating costs. So that's something we'd love to see nationwide.
Okay, great. So Axel.
So very quickly, to answer your good question, because that's of course one of the most critical questions. A couple of information. Number one, in Austin right now with our project in Whisper Valley, average utility costs are $200, $250 per month, kind of average in the year. Our homeowners pay 0 to 50. So you have that $200 gap, and that's the investment capital. By the way, in putting some of those costs into the mortgage, that's the strongest lending party on the table are the homeowners with the capability of getting cheap money, which I find also very important. That's number one. Number two, not a number but another answer. Austin just introduced an interesting requirement. Every home who is older than 10 years, the home seller has to provide an energy audit to the home buyer. And I can tell you from Germany, it's already in place for about 10 years. So as a home seller, all of a sudden you have to prove your energy efficiency. And guess what? If your home is not energy efficient, you are stuck because you don't get what you're expecting. So in a simple way, if a house with all the energy efficiency, good construction methods, is available today because it's affordable, why wouldn't you buy it? I mean, I think it's a very simple solution. I think, and that is what my expectation is, that the investment industry or the investment business, the construction industry, we as a developer, energy companies like Shell, we all have to work closer together to close that gap, because what's not going to work is that we leave it all with the homeowner. Mm-hmm. That's not going to work. Then we are back in that discussion. I saw it about 1,000 times. Oh, should we go with the granite countertop or with the ground source heat pump? I mean, really, who cares about the HVAC? So they go with the granite countertop. And then that happened in the last 40 years. That needs to be changed, and we have to work all very close together.
Well, thank you. Well, on that note, I really want to thank our panelists, Dan, Axel, and Steve, for such a great opportunity to discuss such a difficult topic. I welcome all of you to continue the conversation. I know that we wish we had way more time to talk about it. And I want to thank everyone else for coming. Enjoy the rest of the conference.
Yep. Thank you.